Now let us consider some condition in the same problem. If we consider this problem of cone of this base diameter and height of axis when kept on HP on point of its circumference such that axis makes 30 degree to HP and 40 degree to VP. Now we have to draw its projections with this condition. This is the condition when apex is away from the observer. So in this condition we have to only take care in the final position, that is in the second inclination we have to take some care to satisfy this condition. Let us see how we can satisfy this condition. We have to as usual go for this check, which is the resting plane. Then tilting is about, in case of cone there is always tilting is about corner. Then first inclination which is of the axis with HP at 30 degree and second inclination of the axis with VP at 40 degree. Let us see how to draw its projections in this particular given condition. While drawing projections of this particular cone, we have to first of all start with top view because resting plane is horizontal plane. So first draw top view of the cone, that is a circle of given diameter. From this project its front view, which will be a triangle having axis height equal to 80 mm. Then for the purpose of projections we need to divide this circle into 8 or 12 equal parts. For convenience we have taken 8 parts of this top view and accordingly the points are obtained in front view. Now when axis makes 30 degree with horizontal plane, we have to reproduce this front view such that axis makes 30 degree or base makes 60 degree. So here we take point A dash somewhere. Through this draw a line at 60 degree. This line is drawn at 60 degree and then points are marked along this at appropriate distance. Then distance C dash to O dash is taken along this and this particular front view is reproduced. From this we need to draw vertical projectors. From this we need to draw horizontal projectors, and at the respective intersection we get respective point. Like intersection of A and A we get A, intersection of B dash and B we get B. So likewise mark all the points and join this as per rule. So rule is when we have to complete this top view, we have to look at this front view such that observer, object, plane, this condition is satisfied. So when we look from this side, apex is nearest to the observer, that's why base goes away from the observer. So while joining all these points, first join the boundary points by thick line, and as base is away from the observer, we need to join remaining part of the base by dotted line. That because base is hidden in this case, that's why remaining points on the base are joined by dotted line. Now we have to go for the second inclination. Let us, before we apply the second inclination, which is of the axis with respect to vertical plane. So here axis makes 40 degree with vertical plane. So for this purpose what we need to do, before we apply this inclination, we find that in the top view after first inclination the axis is not seen to its true length. That's why we have to apply apparent angle. Now how this apparent angle is to be found out, for that purpose we first of all draw our horizontal line and mark point O somewhere. Then from this, from O along true angle, first we take a line at angle 40 degree which is a true angle, and then along this true angle we mark true length of the axis. True length of the axis is 80 mm. So along this line we mark 80 mm and we get say point P. Through P draw one horizontal line. Now along this horizontal line again keeping compass pointer at O and taking distance OP1, where OP1 is the plan length or apparent length of axis from top view of the first inclination. So we have to take top view of first inclination, and from that we have to find or take distance OP1 in compass and mark it along this, and finally we have to join O with this. So this angle we get in this case is 47 degree. So apparent angle of the axis is 47 degree. So for applying second inclination, we have to now draw axis at 47 degree. Let us see how to obtain this second inclination. Now here we first draw one line at apparent angle which is 47 degree. So this is the line drawn at 47 degree. Then we reproduce this view. Now while reproducing this view, we have to always keep in mind the condition given. Here the given condition is apex is away from the observer. So there are two possibilities. We can either reproduce this cone this way or this way. So before reproducing, we have to always see that we have to look from this side. So this is the direction of observer. So when we look from this side and when we reproduce this way, then only apex will go away from the observer. If you reproduce this way, then apex will be nearer to the observer. That's why we have to take care that while reproducing, we need to draw this 47 degree line this way. If we draw it other way, how to draw projections of the same cone when apex is towards the observer. Now we see initially we started from this position, then we tilted it so that axis made some angle with horizontal plane, and now after this for the second inclination we tilted it this way so that we find here in this inclination position we see base is nearer to the observer while apex is away from the observer. That's why here we see in the final front view this base is visible. As we see here, all the points on the base are visible, while these are the outlines, they are bound to be visible or thick. Now when we tilt, let us think of the second condition. When we tilt this cone this way, again achieving the same inclination of the axis with vertical plane. In this case also we see that axis is making some angle with vertical plane. Okay, so when we tilt it towards the observer, then we find that base goes away from the observer. So how to draw projections when apex is nearer to the observer? So instead of reproducing, we see this view was reproduced this way. Now we have to reproduce it in the other way. So in that case, so say this is point O, then this is P1, and with respect to this we can mark all other points. So same view, same top view now reproduced in the other way. Now here when we try to obtain the final front view, observer will look from this side and we find here that apex is towards the observer. So if we draw like this, then we find that apex is towards the observer. Now in this condition, if we try to obtain the front view, then as usual we have to draw projections to all these points, and similarly projections from front view, and we can mark all the points. So here point A, which will be going this way, so we will get point something like this. So ultimately, while joining this view, we will have to join the points like this. And as far as the remaining points are concerned, here as apex is nearer to the observer, base is away from the observer. That's why the remaining points are to be joined by dotted line. So this is the difference. You can see the difference in front view. In this case, the base points or whole base is visible, while in this case, some part of the base is not visible. That's why the remaining points of the base are joined by dotted line. So this is the difference in condition when apex is away from the observer and when apex is towards the observer. So whenever this condition is specified in the statement, we have to take care that while reproducing this second or intermediate condition, intermediate position top view, we have to reproduce either this way or this way. So I hope you understood how to reproduce this top view if you want apex away from the observer or if you want apex towards the observer.